In this lesson, we're going to look at dividing radicals, but this time we're going to look at dividing radicals in terms of rationalizing the denominator. Now, there was one lesson where we began our study on dividing radicals, and that's where we used the quotient rule with square roots. And so just make sure you go back and review this lesson. And in this lesson, though, it's a little bit different in terms of when we did this, nowhere did we rationalize the denominator. All right, but this lesson does discuss the fact that there are times when you will have to rationalize the denominator. Now, in the previous lesson, we talked about whether a square root was rational or irrational. That's going to be important, okay, because that word rationalize the denominator has to do with this word rational, okay? So it's important to go back and review this lesson as well. Okay, so let's go ahead and kind of remind ourselves about one of the lessons we had previously. And so just be a couple examples just to remind ourselves about something. So in the previous lessons, and I'm not sure which one it is, but in a previous lesson or lessons, we looked at something like this, and you wanted to divide these two square roots. So number one, we had the square root of 18 divided by the square root of 2. All right, now remember, what we did was we used the quotient rule, because I knew, if you look at this, 18 is divisible by 2. So if I go directly to the quotient rule, this helps me tremendously, because 18 divided by 2 is 9, and then I get the square root of 9, which is just 3. Okay, so that helped, just using a quotient rule right away. And number two, if I look at the square root of 24 divided by the square root of 3, according to the quotient rule, I can write this as 1 square root, and that's going to help as well because, look, 24 is divisible by 3, and so I get the square root of 8, and then I can simplify the square root of 8 further because that's going to be, using a product rule, that's going to be the square root of 4 times 2, which is the square root of 4 times square root of 2, and so the answer is 2 square root of 2 because the square root of 4 is 2. And so that was what we saw in one of our lessons previously where we had a square root divided by square root, and we just went directly to using the quotient rule to simplify this, to divide this. All right. But here's our example now. So now we're going to have this. We're going to have divide, and the directions may say rationalize the denominator. It may not, okay? But you're going to have to know that you will need to rationalize the denominator. Okay, so rationalize the denominator. And that's sometimes what it will say. It may not say this. You just need to know that if you need to rationalize the denominator, you have to. Denominator. Okay, the directions may just say divide. Okay? All right, so let's look at number one. So number one, we have the square root of 2 divided by the square root of 5. Now, the difference between number one here and number one here is that the radicand that's in the denominator, 2, can divide into the radicand that's in the numerator. And you see I got strictly 9. Same thing here. The radicand that's in the denominator here can divide into the radicand that's in the numerator here. But here, that's not the case. 5 does not go into 2 evenly. All right, so writing this as the square root of 2 fifths does not help. It does not help. So using the quotient rule does not help. Okay? But I still want to divide this. And notice that when I look back at number 1 and number 2, if I look at number 3, let's say, and I get 3 divided by 1, and then number 2, 2 square root of 2 is the same thing as 2 square root of 2 divided by 1, right? Notice the denominator is a rational number. The denominator is a rational number. That's a rational number, and that's a rational number. Okay? So what you want to do here, whenever you're dealing with square roots, is you need to ask yourself, first of all, is the square root of 5 rational or irrational? So remember, in the previous lesson, so we said that a square root is rational if the radicands are perfect square. So is 5 a perfect square? No. So it's an irrational number. So note the square root of 5 is irrational. Is an irrational number. So what you want to do is rationalize the denominator, which means you want to make the denominator a rational number. a rational number. You want to make the denominator a rational number. So rationalize the denominator. Rationalize the denominator. Denominator means to make the denominator a rational number. Okay, rational number. All right, so notice that that's not a rational number, that's an irrational number. So here's what you're going to do. Okay, so listen carefully to this. So I'm going to go ahead and rewrite this over, square root of 2 divided by square root of 5. Okay, so just like you did with regular fractions, rational numbers in the past, that you wrote equivalent fractions, you're going to multiply the denominator and the numerator by some number, okay, to get an equivalent fraction. Okay, so you want to write equivalent fractions. And so you want this, though, to be a rational number. So in particular, you want it to be an integer, right? A whole number in this case. So the square root of 5, now listen carefully, here's what I'm doing. The square root of 5, if I multiply the square root of 5 times itself, the square root of 5 and the square root of 5, y'all agree that's the square root of 25, right? Using the product rule. But what I do to the denominator, I do to the numerator. And so the square root of 2 times the square root of 5 using the product rule is the square root of 10. And now I can simplify the denominator. I cannot simplify the numerator because the only perfect square that goes into 10 is 1. So this becomes the square root of 10 divided by 5, and that's your answer. Square root of 10 divided by 5. And notice 5 is now a rational number. 5 is a rational number. So that's what we mean by rationalizing the denominator. Okay? All right, now that was number 1. Okay? Now let's look at number 2. So number 2, we have 12 divided by the square root of, let's say, 7. 12 divided by the square root of 7. Okay, so right away, you know I couldn't use the quotient rule to begin with, right? Because there's no square root in the numerator. So the quotient rule is out of play here. But look at the denominator. What kind of denominator is this? Is this rational or irrational? Is the square root of 7 rational or irrational? Well, 7 is not a perfect square, so it's an irrational number. So I want to rationalize the denominator. So I want to make this a rational number. Now, notice that to make it a rational number, I just multiplied the square root by itself, that radical by itself. And then I ended up with a perfect square, right? So the idea is to get a perfect square in the denominator, in the radicand. So I know that if I multiply 5 by itself, I get a perfect square. And that's the idea. So I want to multiply this denominator by some expression so that way I get a perfect square as my radicand. Well, 7 times 7 is 49, right? In fact, isn't that how we got our perfect squares? So if you go back to your perfect squares, isn't that how we got those? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and so on, right? That's how we got it. So if I want a perfect square, I'm just going to multiply this whole number, the radicand, by itself. So the square root is 7. But what I do to the denominator, remember, you got to make this expression a 1. So keep this equivalent, to keep this as 12 divided by square root of 7. And so I got to do the same thing with the numerator. And so now I get 12 square root of 7 divided by, and then the square root of 7 times the square root of 7, if you need to write it, you're just going to say square root of 49. But you got to go further. You got to simplify this and this if you can. So look at the denominator. The denominator, 49 is a perfect square. So the square root of 49 is now 7, which is now a rational number. The denominator, the numerator, I cannot do anything else with, so that's going to be 12 square root of 7. All right? So I rationalized the denominator. I made the denominator a rational number. The denominator is now a rational number. Now the numerator is irrational because I still have the square root right there. That's not a perfect square, but the denominator is rational. That's the idea. Always to make the denominator a rational number. Okay? All right, so let's look at number 3. So number 3, we have this for number 3. All right, we have the square root of 7 divided by 18. All right, now I know that I can't, that this is not going to help me leaving it as 7 divided by the square root of 18, because 7 and 18, the only common factor is 1. So I'm going to use the quotient rule. I'm going to write this as the square root of 7 divided by the square root of 18. That's the first step. Now look at the square root of 18. Is that rational or irrational? That's irrational, right? Because 18 is not a perfect square. So if you want to go directly and use the ideas that we had earlier, so to get this to be a rational number, I have to multiply the radical by itself, because that's the only way I can get a perfect square, right? Okay, watch. Watch what happens. So now this is one approach. I'm going to come back and show you a different way. So you're going to multiply both numerator and denominator by the square root of 18. Okay, no big deal. That's what many students would do. And so I get the square root of 18 times the square root of 18, and use your calculator. Use your calculator. The square root of 18 is the square root of 18. So 18 times 18 is 324. So you get the square root of 324, right? And then in the numerator, using a product rule, I get 7 times 18. So 18 times 7 gives me the square root of 126. Okay? Now, let's simplify the denominator. So remember, the whole purpose of multiplying the square root by itself is to get this radicand to be a perfect square. Okay? So that means that this right here should be a perfect square. So if you think about it, what number times itself is 324 without using a calculator? Throw the calculator away. What number times itself is 324? Well, 18, because that's how we got it, right? So the denominator is 18. Now, if you didn't know that, just use your calculator now. So we get second square root 324, and you get 18. Okay? Now, let's see if I can simplify the numerator. So I have the square root of 126. Now, the way I would do this is this. Now, listen carefully to this to make things easy on yourself. You see this right here? So 18 is part of this, right? Okay, so watch. If you do 126 divided by 18, you get a remainder 0. So you get 7, a remainder 0. Okay? So what I would do is, because you got to simplify this, so you got to look for a perfect square. What I would do is look for a perfect square other than one that goes here or here. It does not matter. So there's no other perfect square that goes into 7 besides 1. But here, what perfect square goes into 18? 9. So use 9. So 126 divided by 9 equals 14. So you get square root of 126 using a product rule will be the square root of 9 times the square root of 14. And so the answer then will be the square root of 9 is 3. So you get 3 square root of 14 divided by 18. All right, so that's the approach. That's what you would do. So when you get to this point, use one of these factors to help you find a perfect square that goes into that. Using the largest, though. You want to use the largest to make things easy on yourself. And then, oops, sorry, I forgot. This is not the answer. Why is that not the answer? Why is that not the answer? Because you can reduce. Sorry. Okay, so 3 square root of 14 divided by 18. 3 into 3 is 1. 3 and 18 is 6. So the answer is square root of 14 divided by 6, because you do want to reduce. Okay? You want to reduce. All right, so reduce. Okay, now here's the other thing I want to tell you. So whenever there are times that when you multiply the denominator by that same radical, at the end you are at times going to have to reduce. Okay? You're going to have to reduce. And so when we did numbers 1 and 2, we did not have to. And that was because if you look at 5, there is no other perfect square besides 1 that goes into 5 in the denominator. If you look at the denominator in number 2, the only perfect square that goes into 7 is 1. What I could have done, though, in number 3, when I got to this point where I had the square root of 7 divided by the square root of 18, I could have simplified the square root of 18 first. See, here, I could not simplify the square root of 5 any further. I could not simplify the square root of 7 any further. So once at that point, I just went ahead and multiplied numerator and denominator by the radical in the denominator. Here, though, I can simplify this. So if you remember, the square root of 18 is the square root of 9 times the square root of 2. So that's 3 square root of 2, right? So what I'm going to do now is I'm going to rewrite this as the square root of 7 divided by 3 square root of 2. Okay? And now, notice it's still irrational, but you have a square root of 2 as the radical. So now I'm going to multiply both numerator and denominator by the square root of 2. Okay? See over here, I multiply both numerator and denominator by the square root of 18. So here I'm going to multiply the square root of 2, and notice what happens. What happens now? Watch. Using the product rule, the square root of 7 times the square root of 2 is the square root of 14. Isn't that what you got here? See it? And then here, let's think about this. You have in the denominator, you have 3 square root of 2 times square root of 2. Look at this part. Using the product rule, this is 3 square root of 4. And the square root of 4 is 2, so that's 3 times 2, which is 6. And that's what you get. So the point being that it really does not matter. It does not matter which approach you take. It is, though, necessary that you know both approaches, because you don't want to make this so difficult, this part here, to simplify so, at least the numerator, so difficult to where you get stuck. So if you get stuck at that point, then come back and try it this way. All right. So there are two approaches. You can simplify the denominator first before rationalizing the denominator, or you can rationalize, or you can simplify the numerator at some point and then reduce. See, here I had to reduce. Here I didn't have to. All right. So let's do number 4. Number 4, we have the so we have 1 divided by the square root of 7x. 1 divided by the square root of 7x. All right. So notice I cannot simplify the square root of 7, right? Okay. But I do have an x that's in the radical, but that's okay. That's okay. I know that in order to rationalize the denominator, see, that's irrational. I have a square root down there. You don't want a square root in the denominator. You want this to be a whole number, or an expression without the square root. So to make this a rational number, I'm going to multiply the denominator by that radical, square root of 7x. But what I do to the denominator, I do to the numerator. Okay. So then I get 1 times the square root of 7x is the square root of 7x. Now let's talk about this. The square root, using the product rule, the square root of 7x times the square root of 7x, do you all agree that's going to be the square root of 7 times 7 is 49, and x times x is x squared, right? Okay, we're almost done. And this is the square root of 7x divided by, what's the square root of 49? 7. What's the square root of x squared? X. And that's it. You're done. You cannot reduce. Don't stack and reduce the 7s, because that's not a 7 right here. That's a square root of 7. Same thing here. That's not an x as a factor. You have a square root of x as a factor. That's different from a factor of x. So that's your answer. Okay? All right, number 5. Number 5, we have the square root of 2/14. Okay. Now, make things easy on yourself. Don't write it like this. Now you can, okay? You can say the square root of 2 to the square root of, divided by the square root of 14, and then rationalize. But what I would do is I would reduce first. Notice that that's 1/7, right? So that's the approach I'm going to take. And I'll come back and I'll do this one. But that's the approach I'm going to take. So I'm going to write this as the square root of 1 divided by 7. And then, using the quotient rule, I can write this as the square root of 1 divided by the square root of 7. And the square root of 1 is 1, so I get 1 divided by the square root of 7. All right, now here's the question. Is my denominator rational or irrational? It's irrational, so you got to rationalize the denominator. You got to make this denominator a rational number. And here's the process. To do that, you're going to multiply both numerator and denominator by this denominator. Now, notice that 7, the only perfect square that goes into 7 is 1. So if it wasn't, then you'd probably, and you don't have to, that's the approach we talked about here. So if the radicand had another perfect square other than 1, then you may want to simplify that first before doing this part, before rationalizing the denominator. So remember, I'm rationalizing the denominator here. Rationalizing the denominator. So basically what that means is I'm in the process of making the denominator a rational number. What I do to the denominator, I do to the numerator. So I get 1 times the square root of 7 is the square root of 7. Now at this point, most of you know right away what this should be. So what's the square root of 7 times the square root of 7? Simplified. It's just 7, right? Because 7 times 7 is 49, right? So you have the square root of 49, and the square root of 49 is 7. And there's your answer. That's all you do. Okay, now if you had done this, and let me just not say don't, but if you do, then you're going to have to multiply numerator and denominator by the square root of 14, because they're the only perfect square that goes into 14 is 1. So just like this, okay? And so then I get the square root of 2 times the square root of 14 is the square root of 28, right? And then the square root of 14 times the square root of 14. Now right away you should know that that's 14, because any number times itself will be this 14 squared. But if you don't, then just go ahead and work it out. So it will be 14 times 14, which is 196, square root of 196. And so now this should now be a whole number. So the square root of 196 should now be a perfect square. That's how you got it. You say 14 times 14. So if you use your calculator, of course you should already have realized that, but if you just go to your calculator, you get 14. Now in the numerator, you got to simplify this. What perfect square goes into 28? 4. So it'll be the square root of 4 times the square root of 7. And then what's the square root of 4? 2. So you get 2 square root of 7 divided by 14, and then reduce. So 2 into 2 is 1. 2 into 14 is 7. So you get square root of 7 divided by 7. All right. So it did not matter which approach you took, but the point I was making earlier, see how much easier it is if you simplify this first and then rationalize? Now, if you didn't, it doesn't matter. You're still going to get the same answer, but it's a little bit more work to do. Okay? All right, that was number 5. Let's look at number 6. Number 6, let's suppose we had this. We have the square root of 10 divided by x. All right? Okay, so I'm going to use the quotient rule. I'm going to write this as the square root of 10 divided by the square root of x, and now I just got to rationalize the denominator. So notice what I've been doing. See, I still have a square root in the denominator, so what I've been doing is just multiplying the denominator and the numerator by this radical, just like this. And so now using a product rule, I get the square root of 10 times the square root of x is the square root of 10x. And then the square root of x times the square root of x, what is it? What should it be without having to do all that work? It's just what? Yeah, it's just x. But if you did, notice you would say the square root of x squared, right? Because x times x squared. But what's the square root of x squared? It's just x. So you get square root of 10x divided by x. And notice you no longer have a square root in the denominator. So there's your answer. Okay? Number 7. We have the square root of 3x divided by 5. The square root of 3x divided by 5. All right, so again, using the quotient rule, I'm going to write it as the square root of 3x divided by the square root of 5. All right, and notice I have a square root of the denominator, so I want to rationalize the denominator. So in other words, I want to get rid of that square root that's in the denominator. Now 5, since the only perfect square that goes into 5 is 1, I'm just going to it will be a lot easier for me now. So I'm just going to go ahead and multiply both numerator and denominator by the square root of 5. And so then I get in the numerator, using the product rule, the square root of 3x times 5. So 3 times 5 is 15, so that becomes the square root of 15x. The denominator, square root of 5 times square root of 5 is the square root of 25, but you could have just said what here? Yeah, you could have just said 5. So the answer is going to be the square root of 15x divided by 5. And just make sure that 15x is in the radicand. Don't make it look like x is on the outside. It has to be in the radicand. And that's it. You made the denominator a rational number. I don't see a square root in the denominator. So there's your answer. So this is equivalent to this. Okay? Number 8, we have the square root of 1 divided by 50. Square root of 1 divided by 50. Okay, so I'm going to use, just like we've been doing, I'm going to use a quotient rule. So it'll be the square root of 1 divided by the square root of 50. And so the square root of 1 is 1, so I got 1 divided by the square root of 50. All right, so notice the square root of 50 is an irrational number because 50 is not a perfect square. So I got to get rid of that square root that's in the denominator. And you remember, you can, just like we did in number 3, you can go ahead and just multiply both numerator and denominator by the radical. But we saw that if you simplify this further, right here, it may make things a lot easier for you. Okay, so let's go ahead and do it both ways. So what some students are going to do is they're going to say, I'm just going to go ahead and multiply the numerator and denominator by the square root of 50. Okay, you can, no big deal. Because this is as long as this is 1, you can multiply denominator by anything you want. Okay, and so we're going to get the square root of 50 divided by, and if you, again, the square root of 50 times the square root of 50 should be what whole number? Yeah, it should be 50. But if you, and I would put 50 here right away. But if you did, you would probably say that's going to be the square root of 2,500, right? But then you would have to take your calculator and then figure that out. But you don't really need the calculator because how'd you get 2,500? You said 50 times 50 is 2,500. So the square root of 2,500 then should be 50, right? But don't say that's the answer because then you got to ask yourself, all right, can I simplify the numerator? Yes, you can. Because the numerator, 25 is a perfect square that goes into 50. So that becomes the square root of 25 times the square root of 2 using that product rule divided by 50. And then the square root of 25 is 5. So I get 5 square root of 2 divided by 50. And then you got to reduce. 5 and 5 is 1. 5 and 50 is 10. So the answer is 1 times the square root of 2 divided by 10. And you see you had to reduce to the end only because you did not use the, you did not simplify the denominator first. And you did not have to. You have to deal with it at the end. But let's go ahead and do it the other way and see what we would get. So we have, I'm going to go ahead and write this one. So we have 1 divided by the square root of 50. Now if I rationalize, I'm sorry, if I simplify the denominator right now, that would be 1 divided by the square root of 25 times the square root of 2, right? And so that'll be 1 divided by 5 square root of 2. And now we're going to multiply, we're going to rationalize the denominator, so I need to get rid of the square root of 2. So I'm going to multiply both denominator and numerator by the square root of 2. Just the square root of 2. Don't say 5 square root of 2 because then that brings you back to this reducing. It's just the square root of 2. Only use the square root of 2. Don't say 5 square root of 2 because then you're going to have to reduce at the end still. And so I get 1 times the square root of 2 is the square root of 2. And then here, the square root of 2 times the square root of 2 is the square root of 4, right? But what's the square root of 4? Well, the square root of 4 is 2. So I get square root of 2 divided by 5 times 2, and the answer is square root of 2 divided by 10, which is what we had here. See, it's so much easier to simplify first, all right? But I'm going to say this. If you make a mistake, then all of this is going to be wrong, all right? Your answer is going to be incorrect. All right, so that's number 8. Okay, let's look at number 9. So number 9, let's suppose we had this for number 9. We had the square root of 9 divided by 14, okay? And so let's go ahead and use the quotient rule because I cannot simplify 9/14, so I'm going to use the quotient rule. So it'll be the square root of 9 divided by the square root of 14, right? Now notice the square root of 9 is 3, so that's nice, right? But the square root of 14, I gotta rationalize that denominator. So the only perfect square that goes into 14 is 1. So I'm just going to go ahead now and just multiply both numerator and denominator by the square root of 14. And so now the numerator, I have 3 square root of 14. And then right away, most of you should know, or all of you should know, that the square root of 14 times the square root of 14 is just what? 14. All right, if you didn't, you would have said this. Square root of 14 times the square root of 14 is the square root of, and then 14 times 14 is 196. And then if you take the square root of 196, you get 14. Okay? So just remember what you've learned in the past. So you don't have to do all this. You know that the square root of 14 to the square root of 14 is going to be just the radicand 14 because that's how you ended up with 196 by multiplying 14 by itself. And there's nothing you can do. You cannot reduce anything. The 3 and 14 you cannot reduce. Definitely you can't reduce these 14s because that's not a 14 here. That's a square root of 14. That's a different number than 14. All right. So that's the answer for number 9. Okay, number 10, we have 6y divided by the square root of 7. All right, no big deal. We can handle that now. So I cannot simplify this. I'm going to go directly to multiplying both numerator and denominator by the square root of 7 to rationalize that denominator, right? So you want to get rid of that square root that's in the denominator. So 6y squared root of 7, I'm gonna have 6y squared root of 7. And then square root of 7 to square root of 7 is just 7, right? Or the square root of 49, but you know that's what? 7. And you're done. That's the answer. See how easy it is? Number 11, we have the square root of x divided by 49y. Square root of x divided by 49y. So I'm going to rewrite this as the square root of x divided by the square root of 49y, right? But listen carefully to this, guys. Don't multiply the numerator and denominator by the square root of 49y. The reason is because 49 is a perfect square. So make things easier on yourself. Make things easier on yourself. Use the product rule right now. That's the square root of 49 times the square root of y, right? And the square root of 49 is 7. So I get the square root of x divided by 7 square root of y. And now that looks like something we had in a previous lesson, if I can find it real quick, in a previous problem, excuse me. That looks something like this now, right? And so all I got to do is get rid of this square root right here. So I'm going to multiply both numerator and the denominator by the square root of y. Okay, and so therefore I'm going to get, using the product rule, I'm going to get the square root of xy divided by 7. And then the square root of the square root of y times the square root of y is the square root of x squared. Y squared is y squared. And then I can simplify the square root of y squared as just y. So I get the square root of xy divided by 7y. And that's the answer. So make things easier yourself in the process. Now, I'm going to say this. Suppose you didn't see that. Suppose you did not notice that I can write this as this. Okay, no big deal. Let's see what happens. All right, so let me go ahead and rewrite this over. So I have the square root of x divided by the square root of 49y. All right, and let's suppose you forgot that you could simplify this. Okay, let's rationalize. Let's go ahead and multiply both numerator and denominator by square root of 49y. See what happens. Okay, and so I get, using the product rule, this is going to be the square root of 49xy divided by, and then at this point, you should now know that the square root of this radicand times the square root of the same radicand should just be what? That radicand, 49y. But if you did not know that, then multiply it out. 49 times 49 is 2,401. Y times y is y squared. Okay, now let's go off to the side and kind of figure out what this is. So remember, the whole purpose of multiplying this square root by itself is to no longer have a square root here, right? So that means I can simplify this. So let's think about this. All right, so I just wrote the denominator using the product rule. What times itself twice is 2,401? You don't need your calculator. You know what it is. It's what? 49. What times itself twice is y squared? It is y. So that's 49y. So that's why I was saying a while ago, the square root of a radicand times the square root of that same radicand is just a radicand. So it's just 49y. But I got to simplify the numerator. So if you look at the numerator, I have, and I'm going to write the numerator just as this. Square root of 49 times the square root of xy. I'm just going to do that. Over 49y, right? And notice the square root of 49 is 7. So it'll be 7x times the square root of xy divided by 49y, and then reduce. 7 to 7 is 1. 7 to 49 is 7. So I get the square root of xy divided by 7y. And you get the same answer. So notice what you have to go through, though, right? So it's so much easier if you can see it right away. It is so much easier to simplify first rather than at the end. Okay? All right, let's look at number 12. So let's do one or two more. Let's see where we can get. Let's do one more. So this will be number 12. So number 12, we have the square root of x divided by 12y. Square root of x divided by 12y. Okay, so it's kind of like the previous one, right? It kind of looks like that, doesn't it? And see the previous one? So it kind of looks like that, except 49 was a perfect square. 12, though, is not. 12 is not a perfect square, but we can still deal with it. So that's going to be the square root of x using the quotient rule divided by the square root of 12y. Now, just like I said a while ago, you can right now, if you want to, multiply both the numerator and the denominator by the square root of 12y to get rid of that square root. Okay, and you definitely can. There's nothing wrong with that. Nothing at all. So if you want to at this point multiply numerator and denominator by the denominator, that's fine. Okay, but you have to do some work though. So you're going to have to say the square root of x times the square root of 12y will be the square root of 12xy divided by, and then make things easy on yourself. Think about what we've been talking about. The square root of 12x times the square root of 12x is just what? 12x. All right. And you know it's 12x because if you use the product rule, that's going to be the square root of 12 times 12 is 144. Y times y is y squared. And so the product rule says that the square root of 144 times the square root of y squared. And the square root of 144 is 12. And the square root of y squared is just y. There should be a y right here. I'm sorry. Okay? But here's the problem though. That's not your answer because you gotta simplify the numerator if you can. And I can because 4 is a perfect square that goes into 12. So I got to think about the numerator now. So I get the square root of 12 times the square root of xy divided by 12y. And the square root of 12 is I can rewrite as the square root of 4 times the square root of 3 times the square root of xy, right? Divided by 12y. And then the square root of 4 is 2. So you get 2 square root of 3 square root of xy divided by 12y. And then I can reduce. 2 to 2 is 1. 2 to 12 is 6. But I also need to rewrite this as 1 square root. So this is going to be the square root of 3xy divided by 6y. And that's the answer. So notice all the little steps you have to go through. Now make sure you use equal sign to show your steps. Some students, they leave the equal sign off and it very difficult to see their thinking process. And so you don't get full credit. So you got to use equal signs. There's a reason why we use equal signs in mathematics. Now, so that's one approach. Let's suppose that someone, when they got to this point, someone said, oh, I can simplify the square root of 12. Okay, let's do that. Let's see how much different this work is going to be. So I'm going to rewrite this as the square root of 12 times the square root of y. Okay, and the square root of 12, remember the square root of 12 is the square root of 4 times the square root of 3. So that's 2 square root of 3. You all agree? All right, so I'm going to get the square root of x divided by 2 square root of 3 times the square root of y. But now I'm going to rewrite this as 1 square root right here. So I become the square root of x divided by 2 square root of 3y. Now at that point is where we're going to multiply both numerator and denominator by that square root. Just the square root. Don't do the 2 because you have to reduce to the end still. Okay, so make things easy on yourself. So now I'm going to rewrite this as this. And so I'm going to say times the square root of 3y times the square root of 3y. And so now the numerator, when using a product rule, that becomes the square root of 3xy. See right here in the answer? Divided by 2. Now I'm going to ask you, what is the square root of 3y times the square root of 3y? It's just 3y. And now what's 2 times 3y? It's 6y. So I get the square root of 3xy divided by 6y. And that's the answer. That's what we got here. So see, it's a little bit easier. It's a little bit easier to simplify first rather than having to deal with all that at the end. Okay? All right. So that's going to be the end of this lesson. And that's the one where we had to divide radicals using divide radicals by rationalizing the denominator. Okay, so that'll be the end of this lesson.